Welcome to Spring LIB.
In this problem we have, let's see, let me actually draw it here. We have a disc here, a hoop. It's actually a hoop with a string that we're holding, and then we have weight coming down here. And let's see here, yeah, basically, so we have kinetic energy, So this thing is going to unroll. The string is going to unwrap, and the hoop is going to fall. As the string unwraps. So the string is fixed here. So the radius of this guy is 8. The radius of this guy is 8 centimeters. It has a mass of 0.18 kilograms, and it's going to fall. I'm going to say positive is in the y direction. Positive is up, so it's going to fall 75 centimeters. So minus 75 centimeters. The velocity of the center of mass of the hoop, because there's no slipping between the rope and the hoop, is just is r times omega. Let's see here. So then we know for a hoop, J equals mr squared. So the mass moment is mr squared. So the initial energy I'm going to set to 0. I'm going to say this is the reference gravitational potential when this starts. So the initial energy is 0. The final energy is minus mgy, or what did I do here? Yeah, because I used the minus sign in here. All right. So let's see here. So then we have translational kinetic energy and rotational kinetic energy. And so the final energy has to equal the initial energy, so this thing all has to be 0. Which says that, did I do this? Yeah, I got my signs mixed up here. So there should be a plus there. There should be a minus here. And I got it, when I must have copied it wrong because I got it in here. So this should be a plus and this should be a minus. So anyway, this is our equation that we need to solve, and we know everything in here but omega. So m's drop out. We actually we were told m, but we don't need it. Turns out that it drops out, and we can solve for omega. So omega winds up being 1 over r times the square root of minus 2gy. This is not a problem because y is negative, so we get a real solution. Plugging everything in, we get 33.9 radians per second. And so they wanted actually to know the speed of the center. Well, that just is r times omega. We know r, we know omega now. And again, just making sure we can do unit conversions, we get that is 2.71 meters per second. So that's how fast it's going after it falls 75 centimeters.